Industrial and manufacturing teams are in the middle of a major transition defined by forces they can't control, such as supply chain disruptions, rising energy costs, shifting trade and tariffs, ESG commitments, and labor constraints. And these teams are being asked to respond to these pressures without compromising output. Automation and data are the strategies these organizations are using to respond, but they create a specific problem of their own. Every new robot, automated conveyor zone, sensor cluster, and edge compute node needs power and data connectivity, when original electrical design never accounted for these demands. Conventional power distribution is engineered around long-lived production lines and infrequent retooling, not around pushing power and controls out to every zone, mezzanine, and workcell on the floor. That's where VoltServer's digital electricity comes in. It was built for this moment. Distribution centers, process plants, and logistics hubs are being asked to move goods and materials efficiently, safely, cost-effectively, and continuously. To make this possible today, operators are adding automation, sensing, and connectivity in places that used to be purely mechanical, so they can track and route materials in real time across long distances, monitor equipment health and environmental conditions, and enable real-time communication between control systems and edge devices. But to support this, conventional power systems require conduit, coordinating across multiple trades, and working around energized equipment in production areas. In other words, it's slow, expensive, disruptive, space-intensive, and sometimes even a safety risk to support these new loads. Digital electricity gives industrial operators a different path that keeps up with how fast they move. With digital electricity, it's simple to extend power wherever it's needed. Adding a new monitoring zone, communications cluster, or new control point is like adding a network drop instead of starting a new electrical project. Because it's installed using familiar Class 2 and Class 3 installation practices, and often in the same pathways as data, teams can push intelligence and connectivity deeper into facilities without waiting on infrastructure work. The result? Faster response to changing throughput, safety, and service requirements. Instead of running a single product on a single line, manufacturers now support mixed model production, frequent changeovers, and shorter product life cycles. To pull it off, they're introducing more automation and intelligence into production, adding robot and cobot cells into existing lines, or deploying a new vision station between two machines, for example. In order to accomplish this, however, power and data connectivity must be available exactly where these new cells, stations, and systems need to go. If these additions are supported with conventional power distribution, they often turn into multi-step electrical projects that require planned downtime, more hardware and installation work, and reallocating panel capacity. These limitations make it harder to roll out digital initiatives at the pace teams prefer. Digital electricity gives manufacturers an adaptable power layer that fits modern production, so they can treat production lines as living systems. Because it's a fault-managed power system, it continuously monitors for faults and shuts off energy in milliseconds if a problem is detected. Distributed electronics and controls can be safely supported on the floor without replicating costly infrastructure everywhere those devices go. With digital electricity, manufacturers keep moving without waiting on their power infrastructure to catch up. The facilities that will lead are building power distribution that can move as fast as they do. And digital electricity makes that possible. For industrial and manufacturing teams that want to power what's next, digital electricity offers the foundation to build resilient, future-ready operations. Learn more, voltserver.com.